just quick clarification, because in some way I'm representing two things here. One is AssaySoft, which is not that small. We are more than 80 people in Warsaw, in Białystok, but I invite you to the next talk from Kuba Trochim about backups on Kubernetes, because he's the CTO of Infranetis, our startup, as a second company. So, but today we'll focus on serverless on Kubernetes and a little bit different approach. So basically, we want to present you a performance testing that we did for different Kubernetes frameworks. So Kubeless, OpenFaas, and Fission. And we are kind of surprised through the results, and I'll be happy to discuss this afterwards. We tried our best to have a decent results. Then we compare it to pure Docker deployment and to basically serverless from cloud providers. So we'll see how it all works. So what I want to present is our testing approach. Then we'll go through deployment overview of each cluster, what was really deployed. Then we'll focus on high-level statistics, what we found out, and that is something that we can discuss. And then some of the results, some graphs, so we can have kind of the feeling how these frameworks work from the performance perspective, because what we really think is the best benefit of serverless is that pure scalability of the solution that we don't have to think about. And now the question is whether running this on Kubernetes really solves that problem. And we'll make a quick summary of our observations, and I'll be happy to discuss this further. So I want to thank you, Kamil, say thank you to Kamil and Mateusz. Kamil is our DevOps leader, Mateusz is our lead of tests. They helped me with environment setup. So this is a joint work. So thank you guys. So what we did, as AssaySoft, we developed our in-house solution for performance testing. We called it very originally Bolt. And that solution is purely Kubernetes based. And the beauty of it, it's based on a Python framework called Locust that basically is a great tool for running distributed performance tests, but it's difficult to scale it further. So it's easy to go with one node, but if you want to really have a big scalable deployment, then you have to use some external configurations, do it manually. And this is what we were really doing for some time. When we decided, okay, we're duplicating kind of the similar thing, so let's try to build our own platform on top of it. Let's have some graphing so it's easier to analyze the results of what we are testing. So now we'll go back to Bolt. I hope I'll have enough time, so I'll share with you a couple of other results that we run in the meantime. So quickly about deployment environment that we're testing. So we deployed very simple one node Kubernetes clusters on Google. So everything that we're testing is deployed on Google. We wanted to have as similar environments for all these frameworks as possible. So we created, in this case, 4 different clusters. One for Fission, one for Kubeless, one for OpenFaas. And that might be misleading name Docker cluster is basically a custom deployment where we created a simple, same function, just deployed in a simple HTTP framework that serves the response. And we create a deployment for it that basically auto-scales with Kubernetes, not using any serverless framework. So first thing, if we deploy Fission, we get a lot of different deployments, daemon sets, and it's quite heavy. I don't want to go through details of each framework because I think it's well covered already on the internet. There are a lot of great blogs about it, how to start with each of the frameworks, and we don't have that much time, I think, to focus on this. So I highly advise reading a little bit more about this on some existing blogs. We'll just go very high level on the frameworks and focus on the results. So basically, Fission deploys a lot of stuff, and one major benefit of Fission is that it has a pool of functions. So, for example, compared to Kubeless, it's theoretically in that way better that it can have a function pool instead of creating a function per pod, as this is the case with Kubeless, for example. But that makes it more of a complicated deployment. So a lot of stuff is happening on the cluster compared to Kubeless, which seems a lot lightweight. Basically, it has just that controller manager. The remaining stuff is Prometheus for monitoring the cluster. And there's this, basically, we'll be focusing on that get prime function. So we wanted to have something that is CPU intensive. So we implemented a quick function that basically returns nth prime number. So it goes through the loop and finds, for example, 5,000 or 50,000 prime number. So this is something that we can control and have a function that performs some CPU load, and we can control it through the test to see different results. And basically, we'll be calling that function from lots of users to see how it behaves. Unfortunately, we hope that lots of users will be more, but clusters were dying, so we dropped this to lower numbers. So this is Kubeless. OpenFaas is somewhere in between with the amount of stuff that's being deployed. But as well as in here, you can see that this is deployed here as a pod. If we will go here for Fission, we can see somewhere in here that it has this deployment. There's probably some glitch on statistics reading. 39 out of 20. That's how performant it is. But going further, very simple custom deployment. So we basically have Docker image deployed to Google registry. And we get that Docker image out to the same cluster. So as we originally could see, this is a simple one-node cluster with 4 CPUs and 15 gigs of RAM. We think this is good enough to just get some ramp up, so it should be able to run some load in parallel, but we don't have to really scale that up to kill it. And there is, in order to compare stuff, we deployed a Google Cloud function, and that's the simplest deployment. That's like absolutely the easiest, and nothing can compare to how it is to deploy this stuff. Because basically, it's even way easier than Lambda on AWS, because you just go to the browser, paste the code, and that's it, and it's running. So now some of the statistics which were very surprising for me in some way. So we loaded this is just with 500 and 1,000 users. And so basically what we see here is we run the test for 5 minutes and see how many requests we were able to send successfully, retrieve. In this particular graph, one thing that is not surprising is that cloud functions are really kind of handling this the best, because they don't really have the upper limit for the scalability. So we can see that with 500 users, that was 80,000. When we upgraded to 1,000 simultaneous users, it could handle way more. So probably if we have some tests we can review or run it based on your suggestions and see how it goes with different numbers. What is really interesting for me, and we're trying to really figure out why that is happening, is that pure Docker deployment, so meaning a custom deployment with just pod, really works well. And it has its upper limit, and the thing is that if you try to go beyond it, of course, it cannot handle more. But it's surprising that it works way better than, for example, Fission. So now the question is, of course, we probably did something wrong in the configuration. So we tried the default configurations, then we worked on improving the autoscaler suggested by the documentation. One of the, of course, results of our research is that we should probably spend more time on configuring this to really see whether this is a configuration issue or really this is performing that way. Because, for example, Kubeless out of the box was handling kind of similar load, and I was quite surprised because I was expecting that Fission, because of its function pooling, will be more efficient in that way. It seems it's not out of these tests. And the rest remaining stuff, we totally, really at this point, don't know why OpenFaas is dying like right away. Sorry, OpenFaas, it's not about saying anything bad about it. We strongly believe that it can handle load. We just were not able to get it up and running in the form that it would behave similarly to other solutions. So going further, we have same test, but we took the minimum, average, and maximum times between that it took to get the response. And we can see that basically OpenFaas was dying. It was timeouting. It works well with 10 users, but when you tried more users, it was dying. And it's the same cluster deployment. We tried on adjusting the autoscaler in different ways. So probably if you have maybe some suggestions or ideas, I'll be happy to discuss and we can check because this is totally surprising. For other frameworks, this is kind of obvious with cloud functions that these times are basically staying the same independently on the load, which is cool. This is quite well surprising that pure custom deployment is working, but in here we can see that something is happening. So probably if we would go upper with the users, this would start dying. The percentages here in the brackets represent the success rate. So that many requests were successful. So basically here, every request was successfully handled. Here things start breaking, right? And cloud functions still fully perform. So no bad requests. Everything is being returned within this amount of times, which I think is interesting observation for anyone willing to go with serverless deployments. And now going into more details on individual tests. So as we were running tests, you can see that here this is the first test for 500 users. This is the one for 1,000 on Fission. And as we go and scale the amount of users, we can see, and so far we don't have really a good explanation why this drop here happens. I guess that some new pod is being spawned, but it should be handling it more gracefully. Why that drop is happening here and starts from the beginning, and this is a repeated process. So this is not something that's changed. And the test is loading the stuff constantly. So basically each user is sending a request. If the user gets the response, sends it again. So and basically this is not random prime number, but we always want to get like 5,000 or 15,000 prime numbers. So in theory, the time of the function should be the same for each call. The delays and timeouts are happening due to queuing of the calls because there is no capacity or resources to handle it. But we have basically a full success rate here and still have these drops, which we'll see are not happening if we go with Kubeless. So Kubeless seems to have a more stable load, but even for 500 users, it had some drops. So it had problems with timeouts, and then going through 1,000, we see that something bad is happening here, and we still haven't really figured out why that is happening. But probably when the load is hitting 300 requests per second on this cluster, in some way Kubeless really couldn't handle it. So that's interesting. And OpenFaas for us basically didn't work. I have no explanation for that, so I'm really sorry, but we wanted to share this. Maybe someone will have some thoughts, but basically it has some success, but it drops really strange behavior, totally uncomparable with other solutions. And now we can go to Cloud Functions, and we can see a stable load. Nothing is being dropped. Amount of users are going up. Yes, we had a slight increase in time responses, but after a certain time, they basically are at the stable level. So basically, if we will have time, I can go and show you, because we run that for way more users with more CPU intensive stuff, and it was still 100% success rate, which is really cool. And this is interesting, because this is our custom deployment that we basically just did a clear cluster, created a Docker image with the same code, created deployment that auto scales, and the same load just worked. Like stable load, nothing is happening. The only problem happens here if we reach some center limit of the resources on the cluster, some drops are happening, and probably if we would add more heavy users like this, it would be dropping more. And that's what we tested, and that rate was basically worse, right? So quick comparison on the time distribution. So in here we can see that basically the percentiles here look very bad. Like stuff was, it was working, but we have a lot of response times, 30, 40 seconds. It gets better with Kubeless on when it worked. So on average, it seems that it was handling the successful requests properly, but it just had more failures. So I'm not really sure whether that's a better result. With OpenFaas, this is just going crazy. Like it was timeouting, and once again, really hard for us at this time to explain why that happened. With Cloud Functions, this looks very stable, up to 6 seconds. So majority of load was handled very well, constantly. There were some longer responses for the highest percentile. So this is really great. Very stable on custom deployment. So basically, we can just see that while we have resources, everything is being handled very well. If we add more stuff and we start having lag of the resources, we can see that going up for some of the requests, and probably if we would run more users, that graph would look more like Kubeless or Fission. But it is very important for me to say that these are exactly the same clusters. I mean, theoretically, I know that Google can assign different virtual CPUs, but I don't think that would matter in this case. So it's all 4-core CPUs with 15 gigs of RAM. So in theory, it shouldn't really have any differences between serverless solutions and custom deployment. So I'll go through some summary, and I want to, because we still should have some time, I'll open our Bolt platform, and we have some more tests that I would like to share with you. But generally, our observations are this, that generally cloud-provided serverless is probably a way to go if we really care about scalability, because that is working. Like, I'll show you, because we additionally wanted to compare. So we ran that for Google Cloud, and we created the same deployment for Lambda functions, and it's basically behaving very similarly. So scalability is there. Slightly longer response times. We're still investigating, but that's probably some overhead or maybe configuration stuff that we assigned for the deployment of that function. But this works really well. Like if potentially some of the responses take longer individually than, for example, that custom deployment. But whenever you scale, that response stays very stable. which I think is very important when you think about your deployment and have a use case for serverless. It makes sense to think that way. So if you're really about a quick response time, maybe custom deployment might work better. But if this is something that can potentially happen asynchronously or as a job, and it doesn't really matter if it's 200 milliseconds or 2 seconds, we just want to make sure that it runs, that potentially out of these tests at least would suggest to go with serverless for these cases. The other thing is that out-of-the-box deployments for Kubernetes serverless, they don't seem to work just like that. And like everyone is saying, yeah, well, it scales because it's Kubernetes. We know that this is not the case. As an option, as we could see through the results, the alternate way is just to go with that custom deployment, and that worked well in this case. This is what we generally do. We had some couple of approaches for serverless. We thought that making that kind of asynchronicity of the calls through serverless will work. But then, basically, based on our experience, really, we don't see that use case for Kubernetes-based serverless, but we might be wrong. This is just our observation that for our use cases, we don't really see a way to use that and leverage, because it's easier just to have a custom deployment, or if we really have the need that scalability, go with the cloud provider. And one important thing that was mentioned in some previous talks as well is that, yeah, well, cool if you have cloud solution, but what with on-premise? So yes, this might make sense on on-premise stuff. We haven't tested with on-premise cluster. I'm wondering whether the results would be similar, so worth trying. We might do that at some point. And next steps that we would like to do is to compare this really with other cloud providers. So far we tested Google Cloud and AWS with Lambda, and it works really great. I will probably spend some more time on improving that configuration, because we know we did something wrong with, it is possible, I assume it is possible to have a better performance of these configurations. So we want to work on that and maybe update this through some blog entry or something, share the results. And it's very interesting to see, because in here this is a pure compute. So we hit the endpoint, it computes something, returns. We haven't really tested what would be the performance if there is a database connection. And for example, serverless has to reconnect on each call and things like that. That could be interesting next step. We'll try to do that. So for now, that would be it on the slides, but I would like to switch and show you some of the results. I think we have time, right? So basically we have these different scenarios here, and we could see this 500 and 1,000 users compared on different stuff. But for example, what is interesting is if we will go with that custom deployment of our stuff, but we put a more heavy load, it doesn't look that well, because now that custom deployment starts to fail as well. So it looked well for 500 and 1,000 users for smaller compute, but if we put and require more CPU load, it's starting to break. And that compared, for example, to Cloud Functions for the same parameters, basically no glitch, right? So that's where we think that serverless has the real power, that it would be difficult to really scale that function, because how big of a cluster you would have to accumulate, and if you want to just spawn new nodes to add to it, it won't scale that quickly to really handle that load. So this is interesting observation for higher loads. And we have loads for Lambda as well. So similar load for Lambda. We can see that it's working fine. We can see a really great stability here. However, the response times, so if I would compare the same with, so we have Cloud Function one. Yeah, so this is basically the same scenario. 1,000 users with bigger compute load. So this is 15,000 prime number. We see that this is stable as well, around like similar times. This in some way looks kind of more stable, right? But I'm not sure whether that is impacting anything. Both work well. So this is really great. And we have even higher load here. I don't think we have Lambda for that many users, but we tested like 5,000 users. It was just not enough. Like the parameters here were that the users were spawning slowly, so it got up just to 3,000. But we can see that it's not really impacting the behavior of that cloud native. I mean cloud-based solution. So this is what I think from my perspective the most important outcome. This is not surprising that cloud-provided solution just scales better. But we were quite surprised that the load on our cluster will be failing that soon. So I think that's it. I'll be happy to answer any questions. If you would like to see some tests running, we can come up with some parameters and see how it goes. So I'll wait for
a question from me.
Sure.
What was the business use case for these tests?
For this test, the business use case was curiosity. So basically, we just wanted to verify how it will work before we will apply any real business use case, right? Because so far, whenever we were engaged with any requirements, we were just better off not using cloud functions. We had one big project that was using cloud functions heavily. It was a Firebase-based project. I don't know if you're familiar with Google Firebase, and I won't say anything bad about it. There's people saying that, but we think this is a great technology because thanks to the approach of kind of this serverless approach, database, we were using a lot of cloud functions over there. It was handling up to 250,000 users because this was an eventing app when a lot of traffic was going on. It was working really well. We were able to spawn a production-ready application in just 3 months. And it's hard for me to imagine that we could do it any quicker with any other approach. But we knew that we will have to pay price afterwards. And that price was maintenance hell because Google Firebase was based on Firestore, which works on triggers. So we ended up with 150 triggers, and it was very difficult to maintain it. It was still working great, and we never hit scalability issues. We just hit maintenance problems that we were aware of that we will hit. And we migrated when we were ready. That was the plan. We'll migrate to more of a custom architecture, and this is what happened. So right now that system is running on Kubernetes with Mongo running on top of on Kubernetes itself, with backend running as scalable deployments, serving GraphQL to the front end, and it works really well. And this is for now our choice of preference of running projects. So that was the use case for overall cloud functions. For this particular stuff, it was just presenting and comparing.
Short question. Knative?
We haven't tried it yet, so I don't have any response, sorry. But I'll be happy to, that is probably on as a next path to test. But the way I see Knative seems to be more of an extended thing, not only serverless, but eventing and deployments. But yeah, this is definitely something we would like to test. Just did not have enough time to do so.